Okay, so coming off of my last video, I didn't really do all too much since video number 1. It's been a while, I'm a senior. It's hard for me to find time to do stuff. But I'm just gonna work on this model. So yeah. So I took some measurements inside the bike, and I figured out that this battery pack is actually like it fits in really well. So I was actually able to add another row. I know I didn't explain that in the last video, but I'll explain it in this one. My mouse is acting kind of weird, so if you see me do some weird stuff, it's probably because my mouse is weird. So yeah, okay. So I'm just gonna kind of finalize some of this stuff. We're gonna try and have this ready by Maker Faire, which I know is in like 3 days. So we'll see if we can plan it around that. I mean, most of this stuff can be water jetted. It's just 2 folds, some screws, and I've already checked. We have all of this aluminum. We might have the plastic. I'm not quite sure. I don't think we have it all in a 1/4 inch, but is that a 1/4 inch? It might be less than a 1/4 inch. I don't remember what the measurement is. It's 0.1875, which is 3/16. I think I did that to make it cheaper. Yeah. Well, hopefully we have some 3/16 lying around. I think anything, maybe like 3/16 and bigger, maybe a little smaller than 3/16 would be okay, but I'm gonna get kind of skeptical right here because that's a little close. Maybe we could just add 2 of them and it'd be okay. Alright. Well, let me finish this up. Okay. So my idea here is now we have a node sticking out that we can stick a wire to, and instead of like having it come out and connect like we are on the current go-kart, I think that we should secure this in place at least a little bit, because on the go-kart we have 6 batteries, so there's 6 tabs holding this one in place, but right now there's only 4. So I'm kind of worried about wire tensioning with pulling and stuff, but I think I'll make it work. So I might keep it like that for right now. Nah, I probably shouldn't. Okay, so we're just gonna expect this thing to be run in the rain. I think that's pretty reasonable. It is a mini bike. We're probably gonna take it outside. It's gonna be the EVT tool, kind of like Golfy. I'm sure Golfy's been out in the rain a couple times. So let's aim it for waterproofing. So far, pretty good for waterproofing wise. So by the way, guys, for the people that don't know a lot about electronics, power electronics do not care about water all that much. Water has a pretty high resistance to it. Even salt water has a high resistance. And yeah, it could put high voltage on the frame, but we're only talking like 48 volts here. So it's not really that much to begin with. And I'm not really too concerned about exposed connections, but if we wanted to get like real serious here, when there is a wire that is clamped onto this, just put some heat shrink around it. That'll waterproof it. I mean, it's not that complicated. That bar might actually need to be longer. Because if I want to put a layer over it, yeah. Okay. If you don't know keyboard shortcuts I'm using, sorry, it sucks to be you. I'm not gonna slow down. No, I'm not doing a mate. I'm doing insert component. I have a problem with my templates. I haven't fixed it yet. You know what? I think I just... No. Okay, never mind. Nah, it's too short. That looks about a good length. It sticks out a little bit, but you know what? There's gotta be a wire that goes there anyways. It's now that I think about it, I could probably do a rotation. Well, might make things a little easier. Do I already have a rotation axis? Ah, well that's not centered. I think I'll make a rotation axis and just copy these about a rotation. Why is this part 1? Whatever. It's probably because I deleted. Yeah. Okay. I know millimeters are good, but our screws are in inches, our walls are in inches, our height of the walls in inches, because we live in the US and when we buy things they're in inches, so shit. Alright, well, oops. Wait, I thought I converted it to inches. So what this does is I'm thinking about how to put the battery box together, and I don't know, someone might have a better idea, but basically I guess we could just slide it through the wall. Yeah, that actually probably work better. Alright, let me see if I can do that. I hope that wasn't my first one. Where's that? Okay, that was my first one. Maybe. Yeah. Wait, did I make them? I didn't make them separate. Okay, that one has the in place constraint, and that one doesn't. So this one's my first one, obviously, because it's in order. Yeah, it's pretty late, guys. Also, my computer's getting tired. Ah, shit, man, that's on the other side. Alright. Probably gonna end up doing some backwards referencing here, but whatever. I don't know, should I bring him over here? Maybe it'll create problems in the future. I don't know. I'm not sure. Oh, there it goes. Oh, damn it. What? Got an error. Oh good, the error went away. Let's make sure it's still okay. I think it is. Uh-oh. That was not what we wanted. Okay, I know how to fix this. This plane is actually not in the center. So I think if we put it across those two faces it'll work. No. Needs to be over half of one. How about this? This face. And that piece. And come on, that had to have worked. There we go. Yeah, I was like mathematically. Okay. Uh-oh. It's not good. Shit, what happened? I probably discarded my changes. Where did it go? Fuck. Damn it. Sure. Alright. That's all workspan stupid for you. So now you'll see here, and this configuration, that one, that cut's suppressed, and this configuration, this cut's suppressed. So the weather stripping here is a little more complicated, but I think that we can still make it work. Because the top is going to be sliding on and off vertically, it might get caught on the weather stripping, and we don't want it to do that, obviously. But I can't think of another easy way to do it. There's probably a way, but I just can't think of it right now. So I'm just going ahead and go and make that weather stripping go around. And to make this a little easier, I'm just going to go ahead and put some fillets in. Make this nice and easy. Which side is our main part? It's this side. Do some weather stripping. Stripping in the weather. We really should put a fillet on that anyways if we're gonna be doing this, so. Yeah. I did it. Okay, good. See if I can do this pierce thing. Yeah, fuck it. See how easy that was? That was so easy. Why can't I place it? Oh, okay. I might need to add 2 layers of weather stripping because of this little gap right here that's going to exist. Actually, why don't I go ahead and put that in the model? It's not going to be that hard to edit. There we go. It's a little thicker, but I mean the stuff that we have is pretty thick anyways. And this is assuming it's under compression, so this would, I guess, not be as much compression. So hopefully that doesn't wear away too much with time. Now we do have BMS wires. I guess we can just take a hole, drill a hole wherever we want them to come out, and then put a grommet on it. But I'm not really going to worry about it right now. This is 12 cells. I mean, we could use a Deutsch connector, but we don't have enough space for one, so whatever. Alright, now I gotta make this sheet metal part. To be honest, when this leg goes on, it probably won't be this high. I think I liked it how it was before. I'm not trying to spend too much time on this. I mean, I know this isn't like the accumulators. I would probably vary the length based on like another sketch and make it so that it's thick over here but then like thin on top, but I'm not gonna do that. It's too much work for something like this. Alright, so let's see here, we want to insert a new component. How thick is this? 60 thou maybe? Yeah, 60 thou. You can. I figured out that you can only buy 63 thou online. I might have mentioned that in the first video, but yeah. Well, I mean, you can buy 60 thou, but 63 thou is just so much more common and it costs less. So when I measured it, I was kind of concerned that the top of this might be too tall. So it might be coming out pretty close inside the mini bike. There's a bar there that restricts this from there to the top to maybe 6 1/8, and I really don't want it to go past that. But I guess we could take the bar out, but we'd have to figure out another way to add the strengthening member, because it goes across the rear, the pivot. It goes across the pivot for the rear wheel. Yeah. Oh. Well, yeah, that'll do it. Hey, 3D print finished. That's good. Looks good. Good job, Austin. Did a good job on printing. What is this, a 1/4 inch? This hole right here. Now this kind of concerns me a little bit, that node being so close to the cover. It might be okay. I think that I would require heat shrink to be around that, just because of how close it is. Now what did we decide for this, a 1/4 inch? No, one size down from a 1/4 inch, number 10. Or is a 1/4 inch number 10? I don't know, one size down from a 1/4 inch. Wait, wouldn't it show? On the Hole Wizard, wouldn't it show that? Yeah, number 10. Yeah, I got it right, cool. Alright, so we'll use a number 10 for these little connections right here. I kind of like number 10s anyways, so. kind of want it to be the same size if I change it. I was thinking I might use the whole wizard, but I really want him to be the same size. So I'm not going to use the whole wizard. Why won't I go to the middle? It's annoying. It's pretty cool how I made this part after this part, but you can still reference this part to that part. That is pretty cool. So this is to allow for a little bit of air, just in case, for height and things like that. I think I hear a motorcycle. That allows for some length for compression, either up or down. It's probably going to be up, but could go down too. Seems like it's getting close to the wall, so I don't think I should make it any bigger. And then what we'll do is we'll put a washer on this side so the nut doesn't hurt that slot. And then everything will be fine and dandy. Unless we don't have enough room for it, then I guess we'll put the washer on. Just not put a washer and hope it works. So I think that I'm going to, alright, so this is pretty much the design. It's pretty much done now. We need to make one for just a 2-pack. So I might split that up. Hopefully I can utilize some of the top-down designing and just copy this and change the size. That would be nice, but for now this is pretty much done. We could add like a circular output for the BMS wires in here, but like I said earlier, I think it'd be better if we just drill it and then be done with it. But one thing that I know for sure now, I said water does not really affect power electronics that much, and yes, that is true, but there is a lot of dust that can just find its way into places. I don't know how it does it. It's something about the Wilder parking lot. It's just not clean. Got gravel everywhere. So you really got to seal everything off, or gravel's going to get in even some of the smallest spaces. And if gravel comes in here and then goes down there and gets in the bottom of the pack, or in between the wall and a battery, it could abrade the battery and ruin it basically. So we want to try to prevent that by making it dust proof. I think if we put some weather stripping around this, or some stuff, I forgot what it's called. Whatever. Something to seal it. I think that this is a pretty good design. It's pretty simple. It doesn't take a lot of pieces. It's very robust. Yep, that'll last a long time. Yep. I hope this bus bar is enough. It should be. Could probably handle 100 amps and not get hot. Half an inch by, this is probably metric, 1.125? Yeah, that's not metric. It's a weird number. Alright. Okay, well, I'll save this and actually save it this time. Alright, now I need to go to my folder for this. You can tell my thinking is starting to slow down, obviously, because I'm clicking the wrong things. Alright, battery pack. I want to copy that, rename this battery pack 12CL. And this one is 2 cell. So we actually technically only need 13 cells. So thinking about it that way, adding another cell is almost like not even worth designing something for it. So our system is 48 volts. The nominal voltage of a lithium ion is 3.7, and as you can see, that's pretty much 13 volts. We might as well keep it at that because that's what the motor's rated for. I don't think that there would be any problem with going to 14 cells, or maybe 15. I think it would be okay. 4.2 is the maximum. I can't remember what that motor controller is rated for. 63. I feel like it's not rated for 63. Let me go check real fast. Gosh darn it. Well, I was told earlier. It's BJ's motor controller. I don't know. I'm not sure. But with motors, I don't need to have a motor lesson right now. But I learned from Zach, as long as a motor doesn't have brushes, it's okay to overvolt it as long as it can withstand it on the insulation materials. Now that does not mean put 1,000 volts through a motor, because that's what the insulation materials can withstand. There's voltage spikes and several things that could happen because of the inductance of the motors. So you really want to stick with the manufacturer's specifications. But I would say that it's okay to go overvolt just a little bit. This is 48 volt motor. I was thinking about doing a 14, so that would give a maximum of 58.8 volts, which is 10 volts over 48 volts, which is 20% more. Yeah, you know, 20% sounds like a lot to me. I guess we'll see. If the current is raised too high, it's going to break the motor. That's all I can say. Um, well, so the reason why it's so simple, I wish I could show. I wish I could show you a picture of it. But we have some auxiliary battery packs that we made for the go-kart, and they're actually 6, 2 in parallel, 3 in series, and those are really easy to make. I literally used washers and screws to connect the tabs together, almost in the same way I did here, except I didn't punch any holes in them. And then I wrapped it with electrical tape, and I folded a piece of aluminum around it, and that's all I did. It was pretty simple, and I think that I could do that for this extra cell that needs to be in there. And honestly, that cell is going to be so small, I don't think it would have a hard time finding a place to put it. But let me take some final measurements just to make sure that this is good. You could probably check out now if you're actually watching this. But just in case anybody wants to stay, I'll just take these measurements and yep. I almost want to like make like a cardboard mock-up just to make sure it'll fit. I know Mario's gonna have to cut his gas tank in order to make this work. I know that's a fact. 9.2 inches. I hope that we have that much space. Let me check. Looks like we have up to 10 inches of space. An idea is if the pack does not fit this way, instead we could orient it this way. I think that it's okay to have this as wide as that. So 6.277. So pretty much 6.25, because it could be compressed a little more, but I'll try to use 6.3, but this is in fractional inch, so whatever. I'll figure it out. Okay, so that 6.27 fits within the frame. It barely meets it, and the height wise, as if we were to make the battery like this. But if we were to make the battery like this, it would actually be just as wide as the motor. It would come out of the frame maybe a quarter to half an inch, which literally shouldn't even matter all that much. You might not even notice a difference on your legs. And so yeah, I think this is a success. I think this is a good design. I think it'll work well. Wiring is always my downfall. I mean, it looks like there's a lot of space in there, but there's actually not. CAD lies to you when it talks about space. Okay, well now I'm just rambling. Alright, well thanks for watching. Hope you enjoyed it. Bye.